Hey guys, welcome to Brogrammers. So in this video, we are going to discuss the Leetcode problem today, which says make two array equal by reversing subarrays. Okay, so it's a very easy question, right? So the intuition behind this question is, well, we'll discuss the question, what the question is saying. So basically, we are given two arrays, named target and array. Okay, you have to reverse the array such that you will get the target array. Okay, for example, if I have this two arrays target, let's suppose we'll give indexing 0 1 2 3 and 0 1 2, right? So we have this array and we have to make this array equals to target by reversing the digits. Okay, so basically it is given that uh, you are allowed to make any number of steps. Means you can reverse this array into multiple number of times. So basically, if we have array like 2, 4, 1, 3, okay. So what the simple intuition which comes to your mind that let's suppose I'll reverse this 2 like that. Okay. So how it will be, right? So if we reverse this 2 and 4 means it will become 4, 2, 1, 3. You can reverse like the whole array. For example, 3, 1, 4, 2. Okay, so like that you can reverse this array multiple number of times till you get 1, 2, 3, 4, which is your target array. Okay, so the first thought process which comes to my mind is basically if you have all the arrays of target elements, sorry, if you have all the element of target array in the array in the ARR array. Okay, what do I mean? If you have 1, 2, 3, 4 in your target array, right? And you have same numbers, but if it's okay if it's not arranged. In your ARR, let's suppose in ARR you have 2, 4, 1, and 3. Okay, in your ARR. So you can see all the elements of target are present in ARR, right? So we can say that we can arrange this ARR in we have the privilege to reverse this in multiple number of times. Okay, so you can reverse multiple number of times till you get this. So it's possible. It's quite possible. It's it's obvious, right? So what if I'll say that if I'll store the values and frequency of elements of target array in a map, and I will check in the map whether all the elements of the target and its frequency match with the ARR element. Okay, what do I mean? Let's suppose you have one, it like this is an element, okay, and these are the frequency. Okay, we are taking a map, I mean hash map. You have a hash map, and these are the elements, these are the frequencies. Okay, so uh, in target, the first element is 1. Okay, so 1 and its frequency is 1. Next element is 2 and its frequency is also 1. Next element is 3, its frequency is 1. Next element is 4 and its frequency is 1. Right? And we'll have, this is a brute force method which I'm telling right now. Right? And this is a hash map for target. Right? And this is a hash map for ARR. Right? This ARR array. Yeah? So these are the elements, the frequency. Right? So the first element in ARR is 2 and its frequency is 1. Next element is 4, frequency is 1. Next is 1, its frequency is 1. Next is 3, its frequency. Right. So we can say that now what we'll do is simple. We'll traverse both the arrays. Okay. Or you can traverse any one array. Let's suppose we traverse this ARR hash map. Okay. So the first element is this. So we'll check. Okay, the key is 2, and its frequency, or you can say its value is 1. Okay, so find this 2 in hash map of target. If you'll get the key, that's fine. Now another check is you need to check the frequency. So the value this value in the ARR of key 2 is same as the key in target hash map is, if it's same, yes, it's same. Okay, move to this 4, right? So now our, I'll drop this, right? So now our key has become 4 and its frequency is again 1. Okay, so we'll check this 4 in this target hash map. Oh, right, we'll get this 4. Now check whether its frequency is matching with this value. Oh, yes, frequency is matching. So move this I pointer to 1. Okay, so now our key has updated to 1 and its frequency is 1. Now check this 1 in this target hash map. Oh, we get the 1. Now check its frequency. Yes, its frequency is also matching. If its frequency is also matching, means move the I pointer. Now we have 3. Okay, so the key here is 3 and its frequency is 1. Now check whether the key is present in this target hash map. Yes, that key is present and its frequency is also matching with this. That means we have not came across any false condition, right? It means we can arrange this ARR in any number of times. I'll rub this. We can reverse this ARR elements in any number of times, and it is sure shot that we'll get this array, right? Because the frequency of all the elements in this array matching with the target array's elements frequency, right? We'll check one more example. Okay, so let's suppose you have like this. Okay, let's suppose target equals to 1 1 2 3. Okay, and you have ARR, our required array, reverse array, as basically just 1 2 and 3 3, right? So the answer of this, like, you can reverse this array in any number of times, but you will not get the required target. Why? Because you can see that 1 is present here, in 1 is present in target. Yes, 1 is present in target. 2 is present in target. 2, yes. Then 2 is present in ARR. Yes. 3 is present in target. 3 is present in ARR. Both conditions are true. Keys are matching. But the frequency of 1 here is 2. Here frequency of 1 is 1. So if you try any number of steps to reverse this array, you will not get a target array, right? You can check. Okay. But other elements have the same frequencies, right? But here one has, in ARR one has one frequency, and in target one has two frequencies. So you can, if you try to reverse any number of steps, you will get false, right? You can't able to get the target array from this case, right? This is a simple intuition behind this question, right? uh, okay, so basically this is a brute force approach, right? Brute force approach, right? And also you can see we are using one hash map. I'll change the pen, it will be better. So first key point here is we are using a hash map. Okay. So we have some space complexity. For example, we have big of n. We have some sort of space complexity, means more space. Second thing, it is a very, brute force approach. But the fact is brute force will hit 100%, your code bits 100%, right? Okay, so this is a brute force. Now let's write the pseudocode for this. Okay, so what we'll do is we'll run this. We'll write the pseudocode, right? Pseudocode. Okay. So what we need? We need two hash maps, right? And we have to add all the elements to this hash map, right? So let's write the pseudocode, right? So basically we need two hash maps to run this pseudocode, right? Basically let's suppose we start with a function. We are given target array, we are given ARR array, and also in question it is given that target array and ARR array both have same number of. So n equals to store the length of the element, like length of the array. So we are making this first map for target for I equal to n. Let's suppose we say the map name is EMP. EMP is the map for, and it is basically an integer map which stores integer as a element. For I0 and store this EMP dot and its frequency. We are storing the key as well as frequency, right? We'll make one more for map for ARR array. Let's suppose it AMP map, and let's suppose, and we are storing integer elements inside this string, right? Simple. And there's a I equal I0 to n AMP dot put and frequency. So now we have key and its frequency of target and ARR inside our map, EMP and AMP, right? Now we'll traverse. What we'll do is we'll traverse. Let's write it with now traverse AMP and check whether the key and values check whether key and values of AMP present in AMP. So what we'll do is traverse this for now to in Java we have key set operation, right, through which you can traverse basically a for each loop. So basically this help us to get the key as well as values inside app, right? So if we'll check if we'll store the value of AMP's key, value of AMP key, right? So int a equals to dot get key, right? We'll get the value of the first key. Let's suppose we have this 2 3 1 and 4, right? 2 has frequency 1, 3 has frequency 1, has frequency 4, has frequency. So it will take the value of this 2, the first key, right, which is 1. Then what is the intuition? We have to check whether this 2 is present in our target EMP, target hash. So we'll check if EMP dot contains what it will contains a, my bad, so let's suppose we'll name it as key, right? So yeah, this makes much more sense. Have right. So if tmp dot contains key, if the key this key is present in the tmp, right, and if the value, you know, the value tmp dot get key is equals to 8, so this frequency matches with the target hash maps frequency. Then what you have to do is, uh, if it's matching means you don't need to break the loop or return a false. So basically what we will do is we will continue this loop until the values are not matching. Okay, so if at any point the values are not matching, we will return simply as false. So this is simple brute force method which first comes to my mind, right? And you can see this is very clumsy and you have to write lots and lots of code. So we'll move to our next approach, right? We will code all these approaches in the lead code, but first of all, I will explain all the approaches to you. Now we will come to our next approach, that is approach number second approach, right? This approach is very easy, and in this approach, we have space complexity less than the previous approach. Okay, because in this approach we are just using only one map array, right? So this intuition is very simple. Okay, first you have to traverse only single array. For example, if you are traversing target array, right? So whenever you come across any element, let's suppose you have 1, 2, 3, and 4 in your target. So whenever you come across any element in the target array, right? At that index in maps, increment the count. Okay, I'll write it. Then I will do the dry run. Okay. Whenever you come across element target array, then at that index, at that index, increment the count and and whenever you come across any element, let's suppose 2, 1, 3, 4, whenever you come across any element in ARR at this index, decrement the count in map array. Okay, whenever you come across any element ARR, so at that decrement the count, decrement the count in map array, map array. Okay, this is a simple intuition behind it. Okay, so I'll tell you what I mean. So now you can see we have only four elements inside this two arrays, right? 1, 2, 3, and 4. So your indexing will like 0, 1, 2, 3, 4. Till 4 you can add the elements inside the map, right? So you come across the first element in map. For example, your eye pointers are here, right? So you can see we have one in our target. Sorry, my bad. You have one in your target, right? So at first index, increment the count. Okay. For example, you have assigned all zeros, right? So increment the count. So at index 1 in map array, the count has incremented to 1. Simultaneously check in ARR you have 2. So at second index, see I've said already in second index, like in ARR, you have to decrement the count, right? So at index 2, you have to decrement. So count has become now minus 1. Okay, because it was 0 previously, now it is minus 1. Okay, move the eye pointer to next index. Okay, so in target you have now 2, and you know that target elements we have to increment them. Okay, so at index 2 you already have minus 1. So increment means it will again become 0. Okay, it will again become 0, and the same time you have 1 in your ARM. So at first index decrement the count. So it was 1, decrement to 0. Move the I pointer to next index. Now you have 3 in your target. So at third index, target means you have to increment the count. So it was 0, increment to 1. Okay. Now you can see you have same 3 in your ARR. So at third index, again decrement the count. So it was 1, decrement to 0. Move the I pointers, right? So now you have 4. Okay. So at fourth index, if you have target means increment the count. Now you can see you have again 4 in your ARR means decrement the count. Now you can see you have all zeros in your map. Again, after traversing both arrays, you have all zeros, right? So if you have after traversing, if you have all zeros, if you have all zeros in map, it means you can perform any number of steps in ARR to make this ARR equals to target, right? This is a very easy approach, right? Now we'll write the pseudocode for this approach. Pseudocode, right? So you need one map array for this. Map array, right? Okay. And the function have one target array and you have one normal array. So assign a map of integer type. Let's suppose is the name. Traverse the array. Let's suppose n is the length of any. You can take length of any array. Both the arrays have the same length. I is less than I plus plus. Now check. Okay. And also what you have to do is you have to map of map of target of I, then increment the count and sorry, and if you come across the element in ARR, then decrement the count. Okay, then decrement. Now traverse the map array. Okay, so I0, I is less than map dot length. Okay, and I plus. Simple, right? If map of I is not equals to 1, map of I is not equals, then return false. Sorry, not equals to 0, then return false. Else, if you get any non-empty, non-zero element, let's suppose you have 1, then 0, then 0, 0 in your map, right? You have this non-zero element, then immediately return false. It means you cannot make any steps, you cannot make array equals to target if you perform any number of reversal in ARR. Okay, simple. If you don't get this, if you don't hit this condition, then simple, return true, right? Then return true. This is the basic simple intuition behind it. So if I'll talk about the time complexity, means here we are running loop till n in the worst case. Here also we are running loop n in the first case, right? So big of 2n, right? And we have only less, like big of n, let's suppose we have the space complexity. Okay, right? So this is a simple intuition. Right? Now we will check this codes in Leetcode. Right. So this is our first approach. Here the same thing. See, we are taking the length of any one of the array. Let's suppose either you can take target or ARR. Right. We're making this first map for target elements. Right. To store the key of target element and its frequency. Right. Right here. and this is the hash map for ARR hash, ARR array hash. Okay, so this is basically in Java you have the syntax called map integer integer amp name of the map and new hash map, right? So you traverse each and every element of ARR, and this get or default basically it is, if you have that value already inside the map, then it will give the value of that key, and if you don't have that key already, it will return 0. Okay, this is a simple get or default approach execution. Okay? So if you have 0 means it will increment to 1, or if you have some already pre-existing value, then it will increment that value. Okay, then put that key and value inside the map. Okay, so once all the elements of ARR and target are put inside the map, then simple traverse each element in the ARR. You can traverse in any of the two maps, either target or either ARR. Okay, so I am, traversing hash map of ARR. So this is syntax, which is int key amp dot key set. Okay, this is a method to traverse map in the Java. Right, you are storing the value of amp's key in A, and you are checking whether that target map contains that key. This is a first check. If the key is present, then check whether the value of that key is equals to or not equals to. If it's not equals to, directly throw the false, else throw the like, for example, the values are not matching means throw the false. If the key itself is not matching, then also you have to throw this false. Okay, and after this traversal, if you are unable to return anything, right, then at last return true. It means you can change any, you can, reverse any time, can reverse the elements of ARR any number of in any number of steps to get your target elements. Okay, so I'll submit this code. Will get submitted, right? See, now here the space complexity is more. It is 45.15 MBs, right? And it is taking much. It is taking more time also, 8.75, right? Now we come to our next approach, right? So this is our second approach. Here we are, storing the elements of target and storing the elements of ARR in M and N. Okay. Now we are first checking whether, like, for example, both target and ARR doesn't have same number of elements, means true the false. This false is not required actually, but for the safe side I have took this false. And take a map, right? Like this is, the largest number which I can store in the map. If you'll see the constraint, you have 1000 elements. So I have stored 1001 elements inside this map. Right. Now traverse the map, like, traverse the length of any, either target or either ARR. Okay. If you come across any element in target, increment that index the map array. And if you come across any element in the ARR, decrement the frequency or value at that index. Okay, now traverse the map array and check whether any element, at any index, if it is not 0, right, then immediately return false. And after this traversal, if you don't return anything, right, then immediately return true. Means you can reverse this array in some number of steps to get the target. So okay, let's run this code. Let's submit it. Okay. It will get. Here it beats 100% time complexity, and space also it is taking somewhat lesser than the previous approach, right? So this is the two approaches for this problem of the day. I hope you liked the video and understood the concept of hash map and traversing.